Greetings, welcome once again. This is results-oriented preparation and I'm Kenneth. Today we are looking at analytical geometry. We have a sketch there that you can see a triangle that has been drawn on your four quadrants, right? On your Cartesian plane. You've got a P which is 3 and 7, R which is 8 and 2, and then Q minus 4 and 6, S is X and Y, and then T is 2 and D. Now, this is basically elemental analytical geometry. But before we start, always remember that early preparation equals excellent results. Okay, so our first question comes from this sketch. Says determine the gradient of PR. Okay, determine the gradient of PR. All right, we know that a gradient is M, which is PR, right, which is from this point to that point. Okay, and then the formula is y2 minus y1 divided by x2 minus x1. All right. Okay. Now, if you look at that, you will see right here that this is a negatively sloping straight line, right? From this point to that point, it is negatively sloping. All right. Because of that negative slope, before you even calculate, you must know that the answer that you get here is going to be a negative answer. So if you get an answer that is positive, you know that there is something wrong with your calculation. The same applies here. If you're moving from Q to R, therefore the gradient here has to be positive, is it? Because this is a positively sloping line. So let us punch in there. So if you're moving from there to there, this is one way of reminding yourself what your X and your Y2 will be. If you are saying gradient of PR, so it means that we're moving from P to R, therefore R becomes your Y2 and your X2, while this one becomes your X1 and your X2. So we can quickly substitute there, and let us substitute your Y2. Y2 is 2 minus Y1, which is 7, divided by X, which is 8, minus the 3 there. All right, so you've got 2 minus 7 and 8 minus 3, which will give you the negative 5 over 5. So negative 5 over 5 is equals to negative 1. So we know that our gradient here, our gradient is a negative 1. Negative 1 is our gradient. So let us go to the second question. The second question therefore now says determine the equation of the straight line passing through PR. All right, now that we've found the gradient, we will use this gradient to determine the equation of the line. All right. Okay, let's just clean that part. Now they want us to find the equation of the line. Now we know the equation of the straight line here is going to be y is equals to mx plus c. All right. Now there are two methods that I want us to do with this regard, but these two methods must get us to the same answer there. All right. Okay, now that we found the gradient for this line as a gradient of PR being equals to minus 1. All right. Now that we found that gradient, next we know that our gradient will be this part. So we can choose any point that we want to use, either this or that. Okay, let's start by R. Substitute R there. Okay, we've got y is 2, is it? We want to find C. Y is 2 here. Okay, is equals to the gradient is -1, all right, and then x is 8, all right, plus c. All right, now this is -8, is it? -8, if you bring -8, this side is going to be 2 plus 8, so c is equals to 2 plus 8, which is 10. All right? Therefore, let us go back and substitute that here. We've got now y is equals to m is -1, right? X -1, x plus c, which is 10. All right? So -1 times x will give you -x. So this is y is equals to -x plus 10. So this is the equation of that straight line that passes through P and Q. However, as I said earlier, there are two methods to that. The second method that I want us to use is, let us use this method, y minus y1 is equals to m, which is your gradient, open bracket, x minus x1. All right? If you want there, you can put 1 and 2, but it's still the same. You can put y0, x0, it's still the same. Just to say that we're going to use the same, that will put the same coordinate of y here will correspond with our x. We used this one. Let us see whether it will give us the same answer there. Now let us substitute. We'll substitute y minus our y there is 2 is equals to x. We say m is -1, open bracket, x minus our x there is 8, close bracket. All right? Now let us open the brackets. You've got y minus 2 is equals to minus x plus 8. All right? Minus x plus 8. Now let us transpose the 2 that side, and then you'll have y is equals to, again, let us take this 2 that side, so it's going to be 8 plus 2, right? So we've got this minus x, which is minus x plus 8 plus 2, which is 10. Now, if you look at that, you will see right there, you will see that the two methods that we used, they still get us to the same particular answer. All right? So it doesn't matter which method you use there, whichever method that you choose to use will always get you to the same answer. Okay, now let us go to our last question in this section. Our last question. Okay, now the last question says, prove whether PQ is perpendicular to PR. All right, prove if PQ is perpendicular to PR. That is what we want to prove. Is this angle 90 degrees here? All right, now to do that, this is what you need to know. We know that if we say the gradient of PQ times the gradient of PR, right, this will give us -1. All right? Now the gradient of perpendicular lines will always give you -1. That is how we know that the two lines will meet at a right angle there. All right, we already have found the gradient of PR to be -1. All right, so therefore what we need to do is we need to find this one, multiply it by our gradient, and if we get -1, then we know that at least we have proved that it is true or it is false. So we want to see whether PQ is perpendicular to PR. So let us calculate the gradient of PQ. the gradient of PQ is equals to y2, remember we're saying this, we're moving there, all right, PQ, okay? We can see already that this one is going to give us a positive gradient because we're going that way, all right? It is a positively sloping gradient. So you've got y is 7 minus 6, and then the other one is going to be 3 minus, we have negative 4 there, minus 4. All right, so this one will give us equals to 7 minus 1 is 1, 3 minus 1 is 3 plus 4, sorry, 3 minus 4 is 3 plus 4, which is 7. So the gradient is 1.7, all right? 1 over 7 times minus 1 will give you minus 1 over 7. So we know that therefore, PR is not perpendicular to PQ. All right, it is not perpendicular to PQ because the product of the gradient does not give us a positive, a negative 1 there. All right, so please always ensure there that whenever you are to prove that, then you must always make sure that the perpendicular gradients, when they are multiplied, their product will give you a negative 1. All right, I hope you enjoyed the lesson. Okay, send as many questions as possible so we can attend all issues that concern to analytical geometry. I hope you enjoyed the lesson. Okay.